Have you ever been told you look like a family member or a friend? What kinds of things make people look similar to each other? Maybe their hair color, their outfits, their smiles, or their eyes. It could be all sorts of things. But still, even if you look similar to someone else, does that mean you look exactly the same? Probably not. Well, similarity also exists in math. It's just a bit more specific. Let's learn more. So, we just discussed how people can be similar, but what about mathematical figures? Take these triangles, for instance. Do you think they look alike? What do you notice about these figures? I noticed that all of the corresponding angles have the same markings, which means they're congruent. What does congruent mean again? Yeah, the same. I also noticed that each of these three sides is exactly half of the sides in the larger triangle. We could either multiply each side in the figure on the left by 1/2 to make the figure on the right, or multiply each side in the figure on the right by 2 to make the figure on the left. So, mathematically speaking, two figures are similar if their corresponding angles are congruent, and if their corresponding sides are proportional or scaled by the same scale factor. I have a feeling that all our work calculating and applying scale factor in this unit is really going to come in handy here. Let's look at some examples. Are these two figures similar? Let's use our mathematical definition of similarity and scope it out. What do you think? Well, they look pretty similar to me, but our definition says we have to check the corresponding angles and sides, which we can't do without measurements and labels. There we go. That's better. Now we can start by matching up the corresponding angles. What do you notice? I noticed that all the angles in both figures are right angles, so they're all congruent to each other. That's a great start. What about the sides? Are the corresponding sides all related by the same scale factor? Let's see here. What sides correspond with the 5s? Yep, the 15s, since they're the short sides of each rectangle. What is the scale factor between these sides measuring 5 and 15? Well, because the figures aren't labeled as image and pre-image, we can write our fraction with the numbers in either order. We just have to be consistent when we check the other corresponding sides, meaning that if we put the bigger figure's side lengths on top, we need to do that for all the sides we compare. To help us keep track, let's go ahead and label the figure on the left as the pre-image and the figure on the right as the image. Remember, this is just to keep our work consistent. Now that we've labeled the figures, what will our ratio be? Yeah, 15/5, giving us a scale factor of 3 to get from the figure on the left to the figure on the right. Okay, so let's double check this with the other pair of corresponding sides. What is the ratio that compares the other pair of corresponding sides? Yeah, 22 divided by 11, which is 2. What's going on here? Are these figures similar? Well, the scale factor isn't the same between each pair of corresponding sides, meaning the corresponding sides aren't proportional. That means these figures are not mathematically similar, even though they look like they should be. Alright, so we just learned that we can't just trust our eyes when we're trying to decide whether figures are similar. Two figures may look similar, but when we dive deeper into the angles and sides, we might find that they're not actually mathematically similar. Kind of like how two people might look the same, but once you get to know them, you realize they're totally different from each other. Let's try another one. How should we label the pre-image and image? Remember, it doesn't matter as long as we stay consistent when we compare each pair of corresponding sides. I'll label the figure on the left as the pre-image and the figure on the right as the image. Go ahead and pause while you compare the corresponding angles and sides to determine whether or not these figures are similar. Let's go over it. To figure out whether these figures are similar, I need to make sure the corresponding angles are congruent and the sides are all proportional. So, starting with the angles, I see that the angles on either end of the longer flat side of each figure are all marked with one curve. Since they are in the same positions in both figures, they correspond with each other, and since they have the same marking, it means that they're congruent. The angles that correspond with each other on either end of the shorter flat side of each figure also have the same number of curves, so they are congruent as well. So far, so good. Now let's compare the corresponding sides. Since we made the figure on the right the image, and the one on the left is our pre-image, our ratios should have been 2/8, 1/4, and 3/12. All of these fractions simplify to 1/4, so there is a consistent scale factor between each pair of corresponding sides. That, along with the congruent corresponding angles, means these two figures are similar. Here's one more example. Do you think having the figures on the coordinate plane changes how we determine whether they are similar or not? Nope. It's just a different way of representing the size and location of the two figures. Determine whether they're similar and explain how you know. Feel free to explain in writing, using drawings, or in any other way that works for you. Pause while you work. In this case, if we start by checking the corresponding angles, we'll notice right away that they aren't all congruent. So automatically, these figures can't be mathematically similar. I think we're ready for some independent practice questions to make sure we've got this all down. Determine whether each pair of figures is mathematically similar and explain why. Pause while you work and come back to check your answers. Starting with number 4. All the corresponding angles have the same markings, so they're congruent, which is a good sign, but the corresponding sides are not all proportional. Here are all of the side lengths labeled on the figures. If we make the figure on the left the pre-image and the figure on the right the image, we get the ratios 10/5, 6/3, 14/7, and 5/3. The first three are proportional to each other and simplify to 2, but the last one does not. If you labeled image and pre-image in the opposite order, your fractions will be flipped compared to mine, but your conclusion will be the same. These figures are not similar. This is a great example of why it's super important to check every pair of corresponding sides when we're trying to determine similarity. All of the corresponding angles in number 5 are congruent. If you made the figure on the top the image, you would have gotten 5/2, or 2.5, as the scale factor for every pair of corresponding sides. If you made the figure on the bottom the image, you would have gotten a scale factor of 2/5, or 0.4. Either way, the scale factor is consistent for every pair of corresponding sides, so these figures are similar. Wow, we really put our understanding of scale factor to work today. You did a great job determining whether figures are mathematically similar. Keep working on those skills by heading over to today's online practice. And remember, math is everywhere. Keep exploring. Hey, hey.